Today we're explaining system design interviews, the only technical interview that AI can't solve for you. Not the clean design Twitter version from prep courses, but the real implementation where your microservices become a distributed nightmare, your database choices bankrupt the company, and you realize constraint optimization is the difference between senior engineer salary and architect salary. 3 engineers, one who went from bombing 7 FANG interviews to landing staff engineer at Stripe, and 45 minutes of pure architectural trauma. I'm Sam, and someone just asked me to design a system that handles web scale without defining what that means.
I failed 7 system design interviews. 7. The prep courses make it sound elegant, draw some boxes, add a load balancer, use microservices for scale. Reality. I memorized perfect Instagram architectures, but when they asked, what if writes are 100x more than reads, I froze. I hadn't learned to think about constraints, just cookie-cutter patterns.
My job is reviewing system designs before they hit production. You know what I see? Engineers who can code anything but can't design systems that actually work at scale. They choose Kafka for 100 events per day, PostgreSQL for time series data, microservices for teams of 5 people. It's architectural suicide.
I've conducted over 400 system design interviews. The pattern is clear. Candidates who understand constraint analysis get offers. Those who memorize architectures get rejected. It's not about knowing Redis exists. It's about knowing when not to use it.
Dr. Martinez, you're our guide through this architectural hellscape. Riley and Jordan, prepare to explain why constraint thinking became the $25K salary differentiator. No mercy, no hand-waving about eventual consistency.
Let's start simple. What's the fundamental difference between coding and system design?
Coding has right answers. System design has trade-offs. Every technical decision comes with cost, performance, complexity, money, operational overhead. There's no perfect solution, only optimal solutions for specific constraints.
Why can't AI solve system design interviews?
Because AI can't understand business context. It can generate code for design Instagram, but it can't ask what's the budget, team size, regulatory requirements. Read-write ratio, those constraints completely change the optimal architecture.
Give me an example of constraint-driven thinking that changed your approach.
Amazon asked me to design a chat system. Instead of immediately saying use WebSockets, I asked, are messages ephemeral like Slack or permanent like WhatsApp? Group size limits, end-to-end encryption requirements. Those questions completely change your architecture.
How do those constraints change the technical decisions?
Ephemeral messages mean you can use event streams and memory caches. Permanent messages need durable storage with efficient retrieval. End-to-end encryption means you can't do server-side search indexing. Each constraint eliminates dozens of technical options.
What are the core constraint patterns every engineer should know?
Consistency versus availability versus partition tolerance, the CAP theorem in practice. Latency versus durability, in memory is fast but volatile. Cost versus performance, more servers cost more money. Security versus usability, every auth layer adds friction.
How do you quantify these trade-offs?
Numbers matter. High availability means nothing. 99.99% uptime with 4-second P99 latency gives you concrete design targets. Single machine handles 10K QPS, need load balancing above 50K QPS, need distributed storage above 10 terabytes.
Let's talk about the biggest system design interview mistakes.
Jumping to solutions before understanding the problem. I used to immediately say, use microservices, without asking about team size or operational maturity. Microservices for a 5-person startup is architectural suicide. You need 20+ engineers before they provide value.
What about scale requirements?
Not quantifying scale. Millions of users is useless. Is it 2 million monthly actives or 200 million? That's a 100x difference in infrastructure requirements. And usage patterns matter more than total users. Gaming has extreme concurrency spikes. Social media has time zone waves.
What about failure modes?
Ignoring failure modes separates senior from junior engineers. Anyone can design a system that works when everything goes right. Real systems handle chaos gracefully. What happens when the primary database fails? When the network partitions, when you deploy bad code.
How do you approach technology selection?
Every technology has a sweet spot. PostgreSQL for ACID transactions, Cassandra for write-heavy workloads, Redis for sub-millisecond caching. But engineers pick technologies they know, not technologies that fit. I've seen Redis used for long-term storage and MySQL for time series data.
Give me specific examples of constraint-driven technology choices.
Netflix chose edge caching because video files are immutable and geographically distributed. Uber chose real-time location updates because ride matching requires sub-second accuracy. Stripe chose strong consistency because money can't disappear. The business constraint drives the technical choice.
How do cost constraints affect system design?
Every architectural decision has a price tag. Netflix spends $15 billion annually on content delivery. Their latency target directly impacts infrastructure budget. 500 milliseconds globally requires edge computing with massive bandwidth costs. 2 seconds allows traditional CDNs with smart prefetching.
What about team and organizational constraints?
Conway's Law: organizations design systems that mirror their communication structure. Microservices require mature DevOps practices and clear service boundaries. Monoliths work fine for small teams with shared context. Architecture must match organizational reality.
How do you communicate complex trade-offs in a 45-minute interview?
Think out loud in layers. First the business constraint, then the technical implication, then the implementation choice. We need sub-second search, so we need in-memory indices, so we'll use Elasticsearch with enough RAM. Make the logic transparent.
What's the difference between junior and senior system design thinking?
Junior engineers design for the happy path. Senior engineers design for failure, evolution, and operational complexity. They ask, how do we monitor this? How do we deploy safely? How does this scale with team growth? They think beyond the initial implementation.
How should engineers prepare for system design interviews?
Read real system case studies. Netflix's blog about CDN architecture, Uber's posts on location services, Stripe's payment processing docs. Understand the actual constraints they face, not generic textbook examples. Extract the decision patterns.
What about practicing constraint identification?
Take any popular app and ask, what's the primary constraint? For Instagram, it's storage efficiency for billions of photos. For WhatsApp, it's message delivery guarantees across unreliable networks. Then research how they actually solved it.
What's the most important mindset shift for system design mastery?
Stop thinking, how do I design Instagram? Start thinking, how do I solve the constraint puzzle the interviewer is giving me? Every problem is a unique combination of business, technical, and organizational constraints.
Final question, why is system design the career differentiator in the AI era?
AI can generate code, but it can't understand business context or make constraint-driven trade-offs. Companies need engineers who can design systems that scale, evolve, and remain maintainable. That's worth a $25K salary premium.
And as AI handles more implementation, the humans who understand constraints, trade-offs, and system thinking become exponentially more valuable. We're not competing with AI, we're complementing it with the one thing it can't do.
Jesus Christ, so AI commoditized coding, but system design became the career differentiator because constraints are context-dependent, and AI has no business understanding. The $25K gap is just the beginning.
Welcome to 2025. Software engineers write code, but software architects solve constraint puzzles. Guess which one companies pay more for?
This episode was brought to you by Engineer Panic, where we strip away the interview prep hype and show you the constraint optimization reality. Because understanding why your microservices are slowly killing your startup is probably important. We're back, let's talk about the practical nightmare of actually succeeding in these interviews. Riley, what's the most counterintuitive advice you'd give?
Don't try to impress with complex architectures. The best system design is the simplest one that meets all constraints. I got my Stripe offer by choosing a boring monolith with careful API design over flashy microservices. Sometimes PostgreSQL beats distributed databases.
Ask stupid questions. What happens when we get popular? How do we handle Black Friday traffic? What if our main competitor launches tomorrow? These questions reveal constraints that completely change your architecture decisions.
And admit uncertainty. I'd need to benchmark this, or we should A/B test this decision shows mature engineering judgment. Confidence without data is arrogance, and we can smell it immediately.
What about the biggest red flags you see in system design interviews?
Buzzword bingo will use Kubernetes, Kafka, and microservices for scalability. Why? What problem does each technology solve? How do they interact? Listing technologies without understanding their purpose is an instant rejection.
Ignoring operational complexity, we'll just use multiple databases for different use cases. Great, now you need expertise in PostgreSQL, Redis, Elasticsearch, and Cassandra, who's on call when they break. How do you maintain consistency across systems?
In drawing without talking, system design is about reasoning, not diagrams. We want to hear your thought process, your constraint analysis, your trade-off evaluation. The boxes and arrows are just visual aids.
What keeps you up at night about the current state of system design education?
Boot camps and courses teach pattern matching, not thinking. Students memorize Instagram architectures but can't adapt when requirements change. They're optimizing for interviews, not for engineering competence.
The cargo cult mentality. Engineers copy Netflix's architecture for a 100-user app because it scales. They don't understand that Netflix's constraints are completely different from theirs. Context matters more than technology choices.
That we're creating a generation of engineers who can implement but can't design. They can write microservices but can't decide if microservices are the right choice. Architecture thinking is becoming a lost art.
Final advice for engineers who want to master system design.
Build real systems and feel the pain. Deploy something to production, handle real traffic, debug at 3 a.m. Nothing beats hands-on experience with distributed systems failures. The constraints become visceral.
Study failures, not just successes. Read postmortems from major outages. Understand how systems break under real-world conditions. Design for failure from day one, not as an afterthought.
Think like a business owner, not just an engineer. Every technical decision has cost, risk, and opportunity implications. The best system designers understand that technology serves business goals, not the other way around.
This has been Engineer Panic. We've learned that system design is constraint optimization. AI can't solve business context problems, and the $25K salary gap reflects the rarity of genuine systems thinking. Sweet dreams.
Thanks for the reality check. Now I'm going back to explaining why our simple payment system needs 17 different databases, and that's actually the correct architectural choice.
And I need to review another system design where someone chose Kafka for 10 events per day. The struggle continues.
Keep building, keep thinking about constraints, keep questioning technology choices. The future belongs to engineers who understand that system design is applied business logic, not just technical architecture.
This has been Engineer Panic, where system design meets constraint optimization reality. Until next time, remember, every architecture decision is a business decision, whether you realize it or not.